Those who are online are able to hear me?
Yes, sir.
Yes,
We
sir.
have completed till 5.3, right? I mean, the 5.3 we have completed till 7th problem, right?
Yes,
So we are
sir.
proceeding from the 8th one. So you also keep doing it. Don't wait for me. You guys can proceed. Yeah. So what is the question number? Those who are online, keep your videos on. Yeah, what is the 8th question?
Sin square x plus cos square y is equal to 1.
Is equal to sin square x plus cos square y is equal to
1.
I think this problem I solved, no? Didn't? So tell me what is the previous question? Okay, both are similar. Okay. So what is the question? Okay. Sin square x plus cos square y is equal to 1. How to do this? What is the derivative of sin square x? It is 2 sin x cos x plus what is the derivative of cos square y? 2 cos y into y dash is equal to 0. Right. So what will the answer be? 2 and 2 are gone. Y dash will be equal to sin x into cos x divided by sin y into cos y. See, basically you can leave the 2 as it is so that you will get, that's right, you will get sin 2x divided by sin 2y. This is the answer. So check the answer with the book back also. Same, right? Okay. So sin 2x by sin 2y. See, those who are online, I asked you to keep your videos on. Everyone. So I hope this problem is clear, right? Shall I proceed? Okay. 9th one. What is the question? Sin inverse. Sin inverse of 2x divided by 1 plus x square. See, if you start solving it in the normal procedure, it will take time. So you can go with substitution method. What we can do is you can put x is equal to, you will put, see, wherever you have this 1 plus x square, no, put tan theta or cot theta. So mostly put tan theta because the derivative of tan is positive. So put this, so this will be equal to y is equal to sin inverse of 2 tan theta divided by 1 plus tan square theta. This will be sin inverse of, what is this thing? You're there, sin corrector. It's not theta, it is sin 2 theta. So it is sin 2 theta, which is going to be 2 theta itself. So this will be 2 into theta is tan inverse x. So now you can solve it in one step. So so this thing is the same as y is equal to tan inverse x. So what will be the answer? Dy by dx will be equal to, it will be, okay, sorry, 2 by 1 plus x square. Because 2 into derivative of tan inverse is 1 by 1 plus x square. I hope it is clear. Right? You can solve it directly also, but it will be very long. This problem worth is maximum 2 marks. So that was 10th. So what is the question? This is 10th. Okay, sorry. What is the question? Y is equal to? Okay, y is equal to tan inverse of 3x minus 1 minus 3x square. Right? So obviously, what identity is it looking like? Put x is equal to tan theta. So how does it look like? 3 tan theta by, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. It is basically tan. So put x is equal to tan theta here. Y will be equal to tan inverse of, I'm not writing it directly. Can I write it as tan 3 theta? So tan inverse of tan 3 theta is 3 theta. This will be 3 tan inverse x. So y is this thing. So what will be the value of dy by dx? That's the answer. Those are online. I hope you're able to understand.
Sir.
Yeah. Shall I proceed? So what is the 11th one? How many more problems are there? Okay, let's do it fast. 11th one. Y is equal to cos inverse of 1 minus x square by 1 plus x square. So what is that? It is cos 2 theta. So you will basically get 2 tan inverse x. You remember the 6th property that I taught you in inverse trigonometric function. I am assuming you would have written the 6th identity. Go to the inverse trigonometric functions chapter. In the 6th identity, there are 3 subdivisions. What are the 3? Sine inverse of 2x by 1 plus x square, cos inverse of 1 minus x square by 1 plus x square, tan inverse of 2x by 1 minus x square. All the 3 will lead you to the same result. What are they? 2 tan inverse x. Right? This will also lead to the same result. Only thing is, if you don't remember it as a property, what you can do is you are still allowed to substitute and solve. So here, what is the substitution you are doing? You're trying to simplify this expression by substituting x is equal to tan theta. When you put x is equal to tan theta, you will get y is equal to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. This will be cos inverse of cos 2 theta. This will be 2 theta, or this is going to be 2 tan inverse of x. So what is dy by dx? It will be 2 divided by 1 plus x. Harihara Vignesh, I'm not able to see you. Yes, hi Kalyan, you're visible now. Prakash, yeah. Yes. So are you all able to understand? Netra, you also switch on now. Ah, it's on. Okay. Yeah. You're clear with this? So this is the 11th one. Let's do the 12th one. What is the question? See, basically this is, what will you get? So wherever you see 1 minus x square by 1 plus x square, by default, what will you substitute? You will put x is equal to tan theta. By substituting, you get y is equal to sine inverse of, you get sine inverse of cos 2 theta. But sine inverse and cos are, they don't get cancelled, right? Like f inverse of f of x. So here you write it as sine inverse of sine of pi by 2 minus 2 theta. Can I do that? So sine inverse of sine of pi by 2 minus 2 theta will be pi by 2 minus 2 theta, pi by 2 minus 2 into, what is the value of theta? Tan inverse of x. So this is the value of y. Then what is the value of dy by dx? Derivative of pi by 2. 0 minus 2 into derivative of tan inverse x. It is 2 divided by 1 plus x. That's the answer. This you can solve it using the third property also. Sine inverse of, see, observe. The alternate method is, I could have avoided these steps by writing this as y is equal to, I could have written it as pi by 2 minus cos inverse of 1 minus x square by 1 plus x. You're able to understand? So pi by 2 minus cos inverse of 1 minus x square by cos by 1 plus x square will be 2 tan inverse x. So from here you could have directly come to this step. Pi is equal to sine inverse of cos 2 theta. Then cos square 2 theta into correct. That also you can, but that's complicated. No, why do you want to do it? I didn't want to introduce d theta by dx. Okay. So which problem was that? 12th. So I want to start the next exercise. So tell me the next two problems also. 13th. I'll give you the hint. You can solve it. So this is similar to the previous one. Cos inverse of 2x by 1 plus x square is there. No. Yeah. So this one, what will you get? This will be pi by 2 minus sine inverse of 2x by 1 plus x square. According to the property, cos inverse of something plus sine inverse of something is pi by 2. So sine cos inverse of 2x by 1 plus x square will be pi by 2 minus sine inverse of the same angle. Right? But what is sine inverse of 2x by 1 plus x square? 2 tan inverse x. See, that is directly 2 tan inverse x. So basically, you will get y is equal to this value. So what is the value of answer? What is the answer then? So it is minus 2 divided by 1 plus x square. So this is what you will get. Are you able to understand this connection? Done with this? Is it clear? So 14th. Sorry. Y is equal to so you'll put x is equal to sine theta. So y will be equal to sine inverse of 2 sine theta cos theta. So you'll have sine inverse of, so this is y, then what is the value of dy by dx? So 2 sine inverse x. This is y, sorry. So y is 2 sine inverse x. So dy by dx will be 2 by root of 1 minus x square. Okay. But in this case, you would have substituted sine theta because of the value they gave. Look at the domain given for the function. Sorry. So in that case, you will substitute sine. Because go to the inverse trigonometric function. I don't remember the example number. There will be a problem where you will have sine inverse of 2x into root of 1 minus x square. You will get two answers for it. I'll tell you. Sure. Got the example? So it's in page number 28. In page number 28, if you see, there is an example problem. Sine inverse of, is it not similar to this? For the same question, you will have two options. What is it? No. What were the answers? One is 2 sine inverse x, one is 2 cos inverse x. So you will get the answer as 2 sine inverse x if you put x is equal to sine theta. You will get 2 cos inverse x if you put the value of x as cos theta. But you should know when to substitute sine and cos. When will you substitute sine? When the range is between negative to positive, means when it is lying between the fourth and the first quadrant. When it is between minus 1 by root 2 to 1 by root 2. Look at what is happening for 2 cos inverse. So you're able to understand. So both the values will be positive. You can remember it like that. When the domain is having within the positive range, you substitute x is equal to cos theta. When it is having from negative to positive, you substitute it as sine theta. So that is why here we substituted sine theta. Had you substituted cos theta, the answer would have been minus 2 by root of 1 minus x square. It will not match. Clear with that? Now at least functions is making sense to you. That's why it is important. Okay. So last problem, 15th one. What is the question? Secant inverse of 1 by, see wherever you have this 2x square minus 1, right? What will you substitute x as? Recollect the identities. Which identity has this kind of a format? Cos 2 theta. What is cos 2 theta? 2 cos square theta minus 1. So here you need to substitute x as cos theta. Substitute it here. So you will get y is equal to secant inverse of 1 divided by 2 cos square theta minus 1. So what will you get this as? This will be cos 2 theta. 1 by cos 2 theta is secant 2 theta. So secant inverse of secant 2 theta is, can I directly write it? So it is 2 theta. But what is the value of theta? Cos inverse x. So y will be 2 cos inverse x. So dy by dx will be that's the answer. So all the inverse trigonometry based problems, what you're supposed to do is solve using substitution. See, this is not specifically given in your textbook, but this method is called the differentiation by through substitution. It's clear, no? Shall we proceed?
Yes, sir.
Yeah. So listen to this. Now, see, till now, what were the different kinds of functions we saw? No, not those are the operations. What are the kinds of functions that we saw? So if you recollect the concepts, right? Or see, last year, do you remember these functions? This I explained during the functions chapters also. You have identity function, then you have polynomial, then you have rational function, then you have signum, then you have modulus function, and then greatest integer function also, right? So you have all these functions. The two other functions which we did not see till now are exponential and logarithmic functions. Okay. So when you look at this word exponential, right, it is very simple. When I ask you to write the polynomial, what you do? You write something like this: x square plus x square plus 1. Can I call this as a polynomial function? Yes, right?
Yes, sir.
So if I look at this term alone, if I take it as x square, what is the meaning of this? There is a variable x which is raised to the power of some constant number 2. Meaning, if I keep plugging in different values in the place of x, I'll be getting different outputs. So if I substitute -1, I'll get +1, -2, 4. Like that, the output is going to come. Based on that, the graph is going to look like only for x square. The graph is going to be an upward parabola. Something like this. Right? Right? It is going to be an upward parabola. Now, what about an exponential function? If suppose I swap these two, in the sense, instead of writing x square, if I write it as 2 power x, then who is controlling this? Here, the output value is controlled by the base, not by the power. Here, the output is controlled by the power, right? This is what is called as an exponential function, because 2 is raised exponentially. If suppose I substitute x is equal to 1, I get the output as 2. If I substitute x is equal to, I get the value as 2 square. And here I get 2 cube, 2 power 4. This you would have learned in your lower grades. When the bases are same, when you multiply them, the powers will get added. You know all these things, right? Those are actually exponents. So here what you have is, you have 2, 2 square, 2 cube, 2 power 4, something like this. You're able to understand? So these are called as exponent values. If you replace that power with a variable x, you call it as a function. So what function do you call it as? Exponential function. This is an example, that's it. In general, if you write it, no, you write it as y is equal to, for example, b power x, where b can be taken to be a number which is greater than 1. So if you take that number to be greater than 1, right, then this becomes an exponential function. So go to your textbook, go to definition number 3. What is the page number? In page number 126, there is a definition given, right? So what does the definition state? Sorry, I didn't get you. What is it? So that's what the definition is. So this is called as a base. Obviously, you know this. This is called as the base, and the value x is called as the power. If the base is considered to be a value greater than 1, and you raise that value, raise any value of that to any power x, you call that as an exponential function. So basically, if the value of b is greater than 1, and you keep substituting the values into it, right? If you take this as x and this as y, then how will the graph go? when I put, see, b is, let's say 2, for example, because b can be greater than 1. It's not 1. It can be greater than 1. When you, why don't we take it as 1? 1 power x, you cannot call it as exponent, because whatever is the value of power you're going to substitute, it will always be 1. It will be a constant function. So that's why it is defined as greater than 1. So how is it going to look like? Let's take 2. So if I put x is equal to 1, if I put x is equal to 0 for that matter, what will be the value? It will be 0, 1. If I put x is equal to 1, value will be 1, 2. If I put 2, 2, 4, like this, the value keeps on increasing, right? Similarly, if I substitute a value minus 1, so if I put x is equal to minus 1, so 2 power minus 1 is 1 by 2. Wait, I'll take a fresh slide and show it. So what I'm saying is y is equal to 2 power x is there. When I put x is equal to 1, I'm getting y is equal to, sorry, when I put x is equal to 0, I'm getting y as 1. Zero, 1. When I put x is equal to 1, you get y as 2. So 1, 2. X is equal to, I get 2 square. Sorry, 2, I get 2 square. 3, I get 2 cube. So the value is exponentially increasing. What about this side? If I put minus 1, I get, when I put x is equal to minus 1, y is equal to 2 power minus 1, which is half, which is 0.5. Okay. X is equal to minus 2, y is equal to 2 power minus 2, which is 1 by 4, which is 0.25. It keeps decreasing. Right. So where will it become 0? It will become 0 at minus infinity, because it should be a very, very, very high negative number that you need to substitute. So if you observe the graph, right, the graph will be something like this. I'll take this switch. You're able to understand? It keeps going like this. So this is the graph for exponential function. And when you look at something called as infinite series, right, there is something called as Taylor series and Maclaurin series you'll learn in your engineering. As of now, it's not needed. When you write it, right, you write e power x as an infinite variable. Like you write it as an infinite function. You write as 1 plus 1 by 2 factorial, 2 by 2, sorry, 1 square by 2 factorial. You keep writing it like that, which is going to be an infinite series. It would have been given there in your textbook. On the right side, you have seen 1 plus 1 by 1 factorial, sorry, 1 plus 1 by 2 factorial plus 1 by 3 factorial is there. No, that's called as an infinite series, which you need not know. That is the actual definition of e power x. Okay. Now, okay, I'll come to this. So this 2 is there. No, like this, you can substitute any number. You can substitute any number which is greater than 1, so that you get this kind of a function. So there is a special number e that we will always keep substituting, where the value of e is going to be 2.7132. It's a fixed value. Okay, so this value will help us to understand logarithms better. No, it will go down. It will go down, but it will not touch the x-axis at all. It will touch it only at infinity. It will be parallel. It will not be parallel. It will not touch. It will keep on going like. Okay, you have it in the textbook. For 10 power x, they have given, no, in page number. What is the page number? In 126, they would have given for 10 power x. Did they? Right. So E is equal to 2.7132. Say for this number, if you write e power x, right, this is what we are going to see throughout our chapter. So there are two types of exponential function that you're going to see. One is e power x, and the second is a power x. See, they have given the definition as b power x. So instead of b, you replace it with a, where a is now some number which is greater than 1. Are you able to understand? So these are the two exponential functions we are going to see. Now what we need to do is, we need to see what is the derivative of each. So if I have y is equal to e power x, dy by dx is, any idea? It is going to be e power x only. Okay, if at all you want to see the proof for it, it's very simple. Limit h tends to 0. You know the definition of derivatives, right? F of c plus h minus f of c divided by h. So instead of c plus h, I will write it as f of x plus h minus f of x divided by h. You have seen this kind of a pattern somewhere. Where did we see this? When I explained differentiability, right derivative and the left derivative. Right. Only difference is when you write it as right derivative or left derivative, you use c here. Instead of c, if you directly use x, this is called as the first principle of derivative, which you would have learned it last year. So limit h tends to 0, e power x plus h minus e power x the whole divided by h. Is that point clear? So e power x plus h, how can you write it as? E power x into e power h. So what will be common among both? So this can be written as limit h tends to 0, e power x, if I take it out, it will be e power h minus 1 divided by h. Remember, limit h tends to 0, e power h minus 1 divided by h is going to be 1. So e power x multiplied with 1 will be e power x. So that's the answer. Okay. Those are online. Are you able to hear me?
Yes, sir.
Yes, sir.
We can't hear you, sir. Sir, we can't hear you, sir.
Okay, now am I audible?
Yes, sir.
Sir.
I'm asking, did you understand the concept of exponents?
Yes, sir.
Yes, sir.
Okay, so that you remember that no, y is equal to e power x means derivative is also e power x. Now, we are going to see the next one, which is logarithmic function. So what is the definition given? Could you find it? You're still finding it, Ada? 1 minute. I'll write it down. First, let's go with book definition, then I'll explain what is the meaning of. So what is it? Let b be a number greater than 1. So b is a any real number. Okay. Then we say So what is that you are able to understand? They gave some statement, playing with our lives. First time when I see, even I'll feel like that in a statement. But what is the meaning of it? Why do we even need logarithm? If you understand the reason for it, you will understand. Sorry? That exponent itself is solving, no? This also will solve. Huh? See the graph for log, no? You have, so page number 126 are there. See page number 127 in your textbook. Look at the graph. Sorry, 126 left clear kar raha. 126, look at the graph for exponential function. 127, look at the graph for logarithmic function. How are they both? They look similar, right? Actually, they both are inverse operations of each other. They're not the reciprocals, they are the inverse operations of each other. Means if you have an exponent, to solve that exponent, you need logarithm. This is, to put it simple, right? It is like differentiation and integration. If you differentiate something, you will get the integral value. If you integrate something, you will get the differentiation. They're just the operation. That is why the statement is like that. So if I do an operation of log of some number A with respect to B, what is the condition imposed on A? Is there any condition they have given for A? Like how they have given for B greater than 1 and B belongs to R? No condition. Okay, let's try to understand this. Let's try to literally understand this statement. If I have log of 1 base B is equal to X, where A is 1. Okay, so log of 1 base B is equal to X, then what does it imply? So this will go to the other side as, how do you read it? First, log of 1 base B. You read this as log of A base B. Here it is log of 1 base B is equal to X. Then what is the value of 1? B power X. Meaning, what should be the value of X that I need to substitute so that this number B, when raised to that power, will give me 1? That is why we say log 1 is 0. That is why if you see, whenever you do log of 1 base anything is 0. Okay. So from here, just to put it in simple form, right? Exponents and log, they both are inverse operations of each other. So for an exponent, log is an inverse. For log, exponent is an inverse. That is why they both fall under the same exercise. Am I clear till this point? So whenever you take an inverse function, right, you can observe that the graph will always be symmetric with respect to origin. Okay. Now, the next question I want to explain is, this is another important point you have to make a note of. When I talk about logarithm, right, basically, they are classified into two types, depending on what base you are using. If the base B is equal to 10, then you call it as common logarithm. Whereas if the base B is equal to, I told you some number E, right? If you use the base B to be E, you call it as natural logarithm. So basically, when you talk about common logarithm, you write some number. If suppose some number is given as log of 2, it means it is log 2 base 10. Whereas if they give something as ln of 2, it means it is log 2 base E. Okay, but there is one problem here which I want to stress upon. Listen to this. We generally, actually, there is a notation to be followed everywhere, but in your textbook, everywhere they would have given the question as log x. But unfortunately, that log x doesn't mean the base is 10, but the base is E. So whatever logarithm we are dealing in mathematics is not common logarithm, it is natural logarithm. The meaning of it is, If suppose I write log of 1 base 10 is equal to x, or if I write log of 2 base 10 is equal to x, the meaning of this is 2 is equal to 10 to the power of x. So what should be the value of x that I need to substitute so that I get 2? Is what the question is. You cannot find it directly. That's why you have that logbook. So you have that logbook, right? And that logbook, whatever you're doing is basically common logarithm. All the values which are mentioned there are calculated based on the base as 10. Suppose you have something like this, log of 2 base e is equal to x. What is the meaning of this? X will be equal to, 2 will be equal to e power x. See, if this point is registered in your mind, the next steps I can take it forward. Is this point clear? Is this getting registered? Right.
Yes,
This is
sir.
what you need to know as of now. I'm not going in depth to it. Okay, then I'll tell you how the properties have come. 2 properties I'll derive and show. The next one you will understand why it has come. Okay, so you can make a note of this point. If there is anyone having doubt while writing, please let me know. Is there doubt, Amma? You're clear?
Sir,
Tell me.
LN2 வந்து என்ன சொன்னீங்க அதுன்னு சொல்லுங்க.
அது வந்து லான்ரா. LN2 மீனிங் என்னன்னா log 2 base e.
ஓகே சார்.
நான் எழுதி காட்டுறேன். LN2 மீனிங் என்னன்னா log of 2 base e ன்னு அர்த்தம். புரியுதா?
ஓகே சார்.
பட் இது இந்த பாயிண்ட் கேட்டுக்கோ, நம்ம மேத்ல ஃபுல்லா பண்றது வந்து பேஸ் e தான். டெக்ஸ்ட் புக்ல எப்படி கொடுத்திருப்பாங்க, ln ன்னு கொடுக்க மாட்டாங்க, log ன்னு தான் கொடுப்பாங்க. அதனால கன்ஃபியூஸ் ஆகும்.
ஓகே சார். LN ன்னு கொடுத்தா நம்ம log 2 e ன்னு எடுத்துக்கணும்.
ஆமா, ln ன்னு கொடுத்தா பேஸ் e. இந்த டெக்ஸ்ட் புக்ல ln ன்னு கொடுக்க மாட்டாங்க. மேத் டெக்ஸ்ட் புக் சும்மா go and see the problems, no, they will not give it as ln, they will give it as log only. And the log என்ன log ன்னு யாராவது கேட்டாங்கன்னா, what will you say? Is it common logarithm or natural logarithm? The one which we are solving, it is natural. Am I clear with this? Right. So let me know once you have done copying this. Done. தெரியுதா? So give me a confirmation once you are done writing. Done. So first one, you both. Done. Okay. So I'll proceed. Now, let's see what are the properties associated. So what are the properties you already know? Log of log a into log b. இல்ல உனக்கு என்ன தெரியுமோ சொல்லுங்க. log a plus log b. Okay. எப்படி எழுதக்கூடாது? I'm just writing the reverse. Log a plus log b is, this is what I asked. ஒரே டைரக்ஷன்லயே போங்க. ரிவர்ஸ்ல கொடுத்தா கன்ஃபியூஸ் ஆயிடுவாங்க. Same thing. That is what I was about to write. Right? See, thing is log a plus log b is log ab. This I'll show you how it has actually come. If I take the base to be c, some number c, okay. So let's see the proof for it. See, this proof is not from exam perspective, only for you to understand why it is an inverse operation. So concentrate. If suppose I take log of a base c to be x, Okay. If I take log of b base c to be y, am I clear with this? So log a plus log b is equal to log ab base c, provided the bases are same. If they are not same, you should not do that. Okay. So what is the value of a? C power x. What is the value of b? C power y. So what is a into b? So c power x plus 1. Okay. See, as of now, I'll tell you one property. Have that in your mind. Log of c power m base c. Log of any number raised to the power m base the same number is equal to, this will become a multiplication factor, is equal to m log of c base c. So log of any, have this in your mind actually. So this one alone I want to tell, log of any number raised to the power m base of the same number is equal to m times log of that number to the base that number. So why I'm telling that is, AB is equal to c power x plus y. Here I have an exponent. So if I need to solve an exponent, I need to take log on both the sides. So if I take log on both the sides, I'll say take log base c on both sides. Makes sense? Like how you do take sine inverse on both sides, same logic. So taking log base c on both sides, what do I get? Log of AB base c is equal to log of c power x plus y base c. Am I clear to this point? So what will happen to that x plus y using that logic? So it will become x plus y into log of c base c. Now you can ask me a question, log of anything base anything, what is it? See, log of c base c is equal to, if I call it as some number, let me call it as z. Okay, these two are two different things. I'm trying to compare it. So c will be equal to what? C power z. So what is the value of z? So what is the meaning of this? Log of anything base itself is 1. So what can I do here? Log of c base c is 1. So one thing to be remembered, what do I have on left side? Log a base ab base c. But what do I have on right hand side? X plus y into 1. Sorry, it is x plus y into 1. What is x actually? Log a base c. And what is y? Now we are able to understand why the identity works. So you are actually converting it to exponent, again applying the logarithm to get back the value. So this is how you solve any problem, right? So whatever I've explained here is the same way you're going to solve the problems also. This is all you need to do. Okay, please make a note of this. Yeah. Log of x plus 1, provided the base is c. If the base is 10, it is not x plus 1. It is x plus y log c base 10.
Sir, sir, I have a doubt, but not related to this. I like the ma'am.
இல்லடா கிளாஸ் முடிஞ்சதுக்கு அப்புறம் ஃபர்ஸ்ட் இது காப்பி பண்ணு. Let's not deviate. ஏன்னா இது கொஞ்சம் complicated topic.
Okay, sir.
Okay, make a note of this. Actually, this is also a property. Log of anything base itself is 1. This is also actually a property. Am I clear with this? So next question. Shall I proceed?
Yes, sir.
Second is log a base b a base c minus log b base c is how much? Log of a by b base c. Okay. So I want somebody to tell me what are the steps to be followed. Now you can do it faster. We'll try to do it in 2 steps. So I'll take this as x. So what will a be? If I take log of a base, a is c power x. If I take b log of b base c as y, so b will be c power y. So what is a divided by b? I'll write it here itself. A by b is equal to c power x minus y. What should be the next step? Take log what? Log of a by b. So you need to mention which base you're taking. Log base c on both sides. Then that will be equal to log of c power x minus y base c. So what will happen to that x minus y? It will become a multiplication factor. So it will become x minus y into log of c base c. What is log of c base c? You're done. So what is x? Log a base c, y is log b base c. That's it. That is all you need to do. Clear? So third property. So log a power m base a. Okay, you took it base something is equal to m log a. How did you get this? It's the same reverse of what you did in the previous case. You take this thing, no? If I add log a to itself m times, if I add it to itself m times, whenever you are adding the logarithms, what is happening to the values inside it? It's getting multiplied. See, for example, log a plus log b came out to be log ab. So log a plus log a will be log a square. So log a square plus log a will be log a cube. Like this, log a is getting added to itself how many times? M times, no. So can I write this as log of a multiplied with itself m times is going to give me a power m, and whatever is a base I'm not concerned about. So that is why m times log a is log a power m. Clear with this? Okay. Am I clear with this? Okay. So log of anything base itself is 1. This also I told you. Similarly, log of 1 base anything is 0. Log of 1 base anything is 0. That is why I'm not writing the base. Here I need to write it. Okay. So log of 1 base anything is 0. You know the reason why is it so? You will write 1 is equal to base will go that side as the base of the exponent. So 1 will be equal to b power x. What will be the value of x? 0. You already know this. And the next property is log of a base b is equal to 1 divided by log of b base a. Log of a base b is equal to 1 divided by log of b base a. Okay. So these are some properties that you need to know. And most commonly used properties are the first and the second. Those who have already solved this exercise will be knowing it. Right. But what I'll do is I'll solve these problems from this exercise, but I'll connect the previous exercise also. I asked you, few questions where there are multiplication factors. Did you ever solve it with log? Look at the third exercise. The first few problems are there. No. Even in the second exercise, there are few problems. Are there any product of two functions? So that one you can solve using logarithm. I'll tell you how to solve it later, but are the properties clear? No. So one last thing before I wind up is I need to tell you what is the derivative of log. So y is equal to, if I take it as log x, according to your textbook, what is this log x? Base e. So it is basically log x base e. What is the derivative of this? It is 1 divided by x. Okay. So dy by dx is going to be equal to 1 divided by x. Right. If you want to derive this, it's the same logic. Limit h tends to 0, f of x plus h minus f of x divided by h. So what will you get? Limit h tends to 0. So what will you write in the place of f of x plus h? You will write it as log of x plus h minus log x the whole divided by h. Okay. So observe. So this will be limit h tends to 0. Now you know the property log a minus log b. Second property log a by b. So I can write this as log of x plus h divided by x. So it will be 1 plus h by x. Am I right? So you understood, no? X and x got cancelled. You have h by x, the whole divided by, you have a h here. So there is a property which is there from limits of your 11th standard. It says something like this. Limit x tends to 0, log of, can someone complete it? You're there, come on. 1, correct. 1 plus, correct, huh? The whole divided by, how much is this? Correct. So like I told you, e power h minus 1 by h is one property. Log of 1 plus x by x is also one property. If you don't know this, also not an issue. At least now make a note of this. So here, if you observe, what do I have? In the place of x, I'll tell you a technique to apply limits. Always don't look at the variable. You remember it like this. Limit something tends to 0. That something can be anything. It can be x, y, z. I'm not bothered about it. Something tends to 0. Log of 1 plus whatever is here should be here. Log of 1 plus that something divided by something. It can be x, y, z, anything. In a similar case, here what do you have? You have h. So I can change it as h by x. When h is tending to 0, h by x will also tend to 0. Where x is some number. This is only for your reference. Don't write it, okay? Only for your understanding about it. So what I have, limit something tends to 0, log of 1 plus, the same thing is there, h by x is there, but what is missing? The denominator. So I need to compensate it. I'll multiply with x and divide it with x. When I do this, now limit something tends to 0, log of 1 plus something by something. This whole thing is 1. So what is that you're left out with? That's why the reason is, that's why the derivative is 1 by x. Understood? So all these things are for your knowledge. Okay, nobody will ask you an exam, but it's better you know all these things. Right at all. Doubt, no? Clear? So that's all for today. Tomorrow's class, these are the two identities for formula which we need to know. The two things. Conclusion of the whole story is function e power x, derivative is e power x. Function is log x, derivative is. That's all you need to know. Okay, remaining things you know, we'll be solving problems. Okay. So we'll wind up, guys.
Thank you, sir.
Sai Kalyan, you can ask me maybe after the math class. I mean, physics class.
Okay, sir.
Yeah, we'll wind up.
Thank you, sir.